Hi, my name is Charles Robinson, and this presentation is over photorespiration. So here's some general info over photorespiration. It is a biochemical process. It inhibits the Calvin cycle, which fixates carbon and photosynthesis. It results in the uptake of oxygen and the release of CO2. It synthesizes glycolate and has a negative effect on the plant. And we will see more on this in the next slides. Photorespiration and photosynthesis. Okay, so like respiration, photorespiration happens along photosynthesis. So as you know, photosynthesis takes in carbon dioxide from the atmosphere into the plant, and then the plant then produces oxygen and releases the oxygen back into the atmosphere for us to breathe. But as it's releasing the oxygen back in the atmosphere, photorespiration takes the oxygen back in and then produces carbon dioxide. So in this case they work against each other because one is taking in CO2 while the other one is giving it off. And because photorespiration decreases the amount of carbon dioxide in the plant, it limits the growth of the plant, which is a negative factor on the plant. Okay, so here's the process of photorespiration. So oxygen replaces carbon dioxide in a wasteful reaction. As you see, ribulose biphosphate is oxygenated and forms two carbon molecules containing phosphoglycolate and three carbon molecules containing phosphoglyceric acid. So here's the ribulose biphosphate going through and forming the PGA, which is the phosphoglyceric acid, and the phosphoglycolate, and then it produces the CO2 in the atmosphere. Factors that increase photorespiration. Okay, so if your oxygen levels are greater than the amount of carbon dioxide levels, then photorespiration will happen more. I'm so sorry. And then if the stomata is closed during photorespiration, okay, and this is a small opening on the leaf that helps the plant transpire. So it's like releasing gases as well. And if that's closed, then there is no way for oxygen to be released back out because it's all being taken in the plant, and the photorespiration is then taking all that oxygen and producing carbon dioxide. And then if plants are water stressed, and when plants are water stressed, they tend to close their stomata so to decrease the amount of transpiration going on. So here are some adaptations that plants have developed to work against photorespiration. CAM, which stands for crassulacean acid metabolism. And this is your succulents and more of your desert type plants that are under constant heat stress because in the desert the heat is unimaginable, and they tend to open their stomata at night. So because if it's open during the day, then they're just losing large amounts of water, and they can't afford to do that. And then C4 metabolism, and plants with this adaptation, they have a different leaf anatomy and they fix carbon dioxide. Okay, so you're probably asking, well, why do plants go through photorespiration if it's such a negative effect? Well, it's been said that a long time ago there was little oxygen in the atmosphere, So the ability to distinguish between oxygen and carbon dioxide wasn't a problem for the plant. But as oxygen levels rose, photorespiration began to be a problem, which is, kind of hard to believe, but we're uncertain on that part. And then also, photorespiration can help the plant from the harmful effects of too much internal oxygen. This occurs when the plant is exposed to intense light, and photosynthesis generates oxygen very rapidly. So photorespiration will then consume some of the oxygen down to levels that aren't harmful to the plant. And this one makes more sense because in such cases, like for instance, if in too much heat when the plants close their stomata, that's less oxygen that's being released through the leaf, and so there's more oxygen being built up in the plant, and that's when photorespiration can help with that by consuming that and producing carbon dioxide. Here are some quiz questions. What is photorespiration giving off? What's one factor that increases photorespiration? Is photorespiration a more negative effect or positive effect? What's an adaptation that some plants have against photorespiration? And there were several mentioned. And how can photorespiration be beneficial to the plant? And here are the references. And that's it. Thank you.